Today we're going to look at the four-pan balance and see how that can be used to introduce some important concepts about equations. A typical balance just has two pans, one on either side of the center point. So let's start there and see how it behaves just as we would expect if we put something in one of the pans without putting a corresponding amount in the other pan. Then it's going to lean towards the side that is heavier. The only way to make it balance is to have the sands. So that's the initial concept that we want to communicate about. What equals means that the symbol equals and balance, they represent the same quantity or the same amount. Now with the four-pan balance, we have an additional pair of pans, and what happens here is if I put something in this outer pan, it actually lightens the amount in this pan. So now, while I had put two discs in this yellow pan, I put one in the red pan, which lightens it by one amount. So it will balance if there's only one in the other yellow pan. So this is a way to introduce the effect of negative quantities. Here we're showing that a positive 2 plus a negative 1 is equal to just a positive 1. So we can see how there's negative pans, and it would work on the other side as well if we put a negative over here. Okay, now the net amount on that side is actually 0. So I'd either have to make a dip over here by putting a second disc in the red pan to kind of balance that out, or I could remove all of these discs altogether. When I remove the same amount from the yellow and red pan on the same side, I'm really removing 0. So I refer to that as removing 0 pairs. And in this case, there's a 0 pair on the other side, nothing on this side, so nothing obviously is 0. So here we're showing that a positive 1 plus a negative 1 is equal to 0. What we're going to do next is actually look at how we could use the four-pan balance to solve an equation. Now this requires some preparation on the part of the teacher. The teacher has to decide ahead of time on what equation and what the solution is. So the equation that we're going to be looking at is this one here. Let's see, can you see that there? X minus 6 equals 3 minus 5 minus x. Now in order to translate that into the four-pan balance, we're actually going to think of those subtractions as being adding the opposite, so adding a negative. In other words, we're actually going to rewrite the equation this way as x plus a negative 6 equals 3 plus a negative 5 plus negative x. So I'm going to model that in the four-pan balance now. I have prepared some canisters. These little canisters are my unknowns. They're only unknown to the student, though they're not unknown to the teacher, because the teacher had to put in an appropriate amount of weight to make that physical balance actually work. It turns out that the canister itself is equal in weight to one disc of chip, and then in addition I have put a second disc of chip inside of it. So each of these, I've got a total of 4 canisters, and they're each equivalent in weight to 2 discs, but I'm not admitting that to the students initially. I'm just going to prepare them as unknowns for the students. Okay, on the left-hand side of the equation, I had an x and negative 6, so I'm going to model that this way. Okay, and then on the other side, I had a positive 3 plus a negative 5 plus a negative x. So if I've done everything properly in the preparation, that is an equation, which means the two sides are in balance. So you can see that this is physically balanced. Okay, now I can start to do some operations. Typically, the first thing that we do is to try and simplify on just one side of the equation if that's appropriate. So think back to this equation that we had. Okay, x plus a negative 6 on the left. There's nothing to simplify there. But on the right-hand side, we have 3 plus a negative 5 plus a negative x. I can combine the 3 plus the negative 5, and that will simplify to just negative 2. Now, that means what I'm going to physically do is remove 3 zero pairs. Okay, I can either do it one at a time by taking one out of each of those positive and negative pans. That's 1 zero pair. Or I could do a couple at a time. So I realized I'm going to need to take away 2 more from each of the yellow and red pans. So 2 more zero pairs. Okay, so now I have simplified that right-hand side of the equation. So I'm going to write down what this simplified version states. Okay, and this I would do with my students on either the chalkboard or the whiteboard so that they would get used to the correspondence between what we're doing to the balance and how we would write it on paper and pencil and a chalkboard. Okay? All right, now I'm ready to start thinking about isolating that variable x. Right now there are x's on both sides of the equation, and that's not what I want at the end, of course. So what I might decide to do next is to add an x to both sides, and that's going to allow me to have a sum of 0 on this right-hand side. So let's do that. So with the balance, I'm going to add a positive x to both sides. And put another one of these canisters in those yellow pans. Notice how, because I added the same amount of weight to both sides of the balance, it remains in balance. And this is what we want to keep reiterating with our students. If I change the weight on one side of the balance, I need to do that same change to the other side of the balance, just as when I solve an equation, adding x to the left side of the equation means I better add x to the right side of the equation to keep things balanced. Now looking at the right-hand side, I have this 0 pair of a positive x plus a negative x. This I can simplify. I can just remove that 0 pair and things stay in balance. So let's show that as it would be written. I've added x to both sides and removed that 0 pair. So that gives me now this form of the equation. I've got 2x plus a negative 6 on the left equals just negative 2 on the right. And I can see that that is what our balance shows as well. Okay, the next step would be I want to get rid of the negative 6 over here. So to do that, I need to add a positive 6 on the left, but of course I need to also add positive 6 to the right to keep it in balance. So I'm going to do that. This is going to be a little tricky because there's not much room in that pan. But there, by doing it, I can see that the balance has stayed in balance. And on the left, now that gives me some 0 pairs. So I'm going to go ahead and take away the 6 positive and the 6 negative all at the same time. And that should leave me a balanced balance. Of course, with paper and pencil, what have I done? I've got a little more simplifying I could do. Let's just show this. Yeah. So on the left-hand side, I removed the 0 pairs so that I would have just 2x. But notice on the right-hand side, I haven't simplified yet, the negative 2 plus positive 6. So that means I can take away 2 0 pairs on the right-hand side here. Let's do that. That will make my life simpler. here. Okay, still in balance because removing 0 pairs doesn't change anything. So now what I have got is that 2x equals 4. So I see that on the balance as well. 2 canisters, 4 chips in this yellow pan right here. Now here at this step, we have to think about the meaning of division. I've got 2 equal-sized groups that total 4. So I could physically make these chips into 2 equal-sized groups in order to illustrate that each one of those canisters corresponds to a stack of 2 chips. So something like that would be the way that we would show the final division step on the balance, just to reinforce for the students what that means or how we would write it. I would go ahead and show the 2x divided by 2 and 4 divided by 2, and then of course the final step after I simplify is that x equals 2. And this I can check by actually taking one of these canisters and opening it up, remembering that the canister itself has the weight of 1 chip, and so then when I see that there's 1 chip inside plus the canister itself, I can verify that we did everything correctly. We did all legal moves to our balance. A couple little things to keep in mind about this balance. Let me go back to making it balanced so it looks a little nicer. The unknown could never be negative because the canister itself weighs a positive 1. So you couldn't do an example where x equals, say, negative 2. Also, because the balance itself is all just physical manipulations, we have to make the effort to be writing down the steps as we go along. Maybe a student could do this on the chalkboard or the whiteboard alongside as the whole class is watching the balance, because we need to reinforce the connection between the balance and what we're learning about the equal symbol and about legal steps when we're solving equations. So that's how the 4-pan balance would be used.